undergrad here at UT in biosystems engineering. He's pursuing his master's. And currently his focus of research is sensors and the implementation.
Thank you for that introduction. Again, my name is sPicket1, and so what I'm working on is, let's go ahead and just throw this title out there. It's the development of and evaluation of a wireless sensor network for monitoring geospatial and environmental parameters. And obviously that's really long and it's meant to go on the front of a piece of paper and wow people. So let's kind of talk about what all that means without getting too in depth on any one particular word. So first I'd like to thank my committee members, Dr. John Wilkerson, who is my major advisor, Dr. John Buchanan, and Dr. Kimberly Gwynn. So a little bit of background, what this particular project is aiming towards is really looking at high value production crops and seasonal specialty crops such as flowers and fruits and the sort, and plant material research. We're trying to design a wireless sensor network that will give us a little bit more insight into what's going on in these experiments and also this research here. And so you can look at it in two different ways. You've got open air farming and greenhouse, and these are obviously on two different ends of the spectrum. So let's kind of talk about the pros and cons of each of them. Well, the pros and cons of your open air farming is, the pros of that is it's going to be large scale. You can put 100 acres of pine trees and you can grow them and you can sell them as Christmas trees. It's very flexible, so you can grow pine trees on it today. In a year you can grow corn, and it's stationary. You plant a tree there, it's going to be there, and so you cut it down. You plant a plant there, it's going to be there. The cons of that is the variability of timing. With a lot of the plants that you put in the ground, the way they bloom, the way they fruit, it's dependent on the temperature or the soil or the amount of sunlight that they get. So you're really restricted by the weather, and you're in an open environment. So you can't say this particular plant got X amount of rain. You can say, okay, this field got on average this much rain, but it's really an open system. You can't say specifically. And so that brings us to where we're really going to focus on, and that's our greenhouse. The greenhouse, the great thing about it is a closed system. So anything that goes into it, we can say, okay, we put this much in there. Anything we take out of it, we can monitor that. We can do that with the use of electronics. And the great thing about our greenhouse is we can do a lot of control. We can do the control of our seasonal products. I've mentioned a couple here, poinsettias and chrysanthemums. Really, poinsettias have no value before Thanksgiving and no value after Christmas. It's during that short window that it's really got all of its value just because it's so seasonal. And so if you miss that window, then you've pretty much got a whole greenhouse full of things that aren't valuable to you at all. They're just kind of trash or whatever you can get for them. And so that environmental control is really one of the best pros about our greenhouse system, and it also makes it repeatable. Okay? So the cons of that really are going to be the fact that it's high maintenance. It's very expensive energy-wise, and also the facility costs when you compare it back to an open-air farm situation or open-air growing situation. It's going to be comparatively small scale. So while we're talking about being able to grow acres of plants inside of a greenhouse, we could do hundreds of acres or thousands of acres outside of the greenhouse. And it's very crop limiting because of the fact that the size of the greenhouse, you have to say, okay, it's feasible to grow this in a greenhouse and not that. And it also requires that constant input. So if you don't water them, they'll die. In a crop outside, if it rains, then that's an input that you didn't have to do. So what is the objective of our particular project? And so we've gone with a three-phase model. In phase one, the biggest idea here is we're going to create a proof of concept design and prototype of this sensor network. What we're trying to do is be able to figure out what is the climate around our plant. And so if we can imagine this as the potted plant and I've got my sensor in it, what is the environment around that and how much water is in there? And so that would be representative of the plants around it. And so we're really looking at this as a production in a greenhouse type production scenario or a research environment for if you were doing lab scale research. And so in phase two, what we're going to do is we're going to say, hey, we're going to give this prototype to the client, and we're going to say, this is what we have. What would you like to see to change about it? And so they're going to say, okay, these sensors we like, those things we found out weren't as important as we thought, and we'll go back and we'll change out what sensors that are in there and get closer to a final design. once we've done that, we can take a look at power and we say, okay, we've got these sensors, they require this much power, and we can cause them to turn on and off and get the amount of time we need out of the battery. And then we can also optimize cost and size as well. And those are a really big thing, because when you look at a pot this size, obviously we could have all kinds of different sensors in here in a data logger, but if it's bigger than the plant, it's kind of useless. So in phase 3, what we'll be doing is outlining a path to production. I'll be creating an outline that says, okay, this is, if you were going to mass produce this, this is how you would go about doing it. And in the end, we'll transfer that to the client. So how are we going to go about doing this? Well, like I said earlier, there's a lot of sensors out there that are already out there. There's obviously temperature sensors, soil temperature sensors, humidity, soil moisture, and leaf wetness. These are all sensors that are currently on the market. And you can hook them up to a data collector, and again, you can put up the system together right now probably in an hour. But the thing is, we're not looking at each of those sensors individually. We're trying to incorporate them into a system. And that system has to be small enough to go onto a popsicle-sized stick to go into our potted plant. So that's really what we're trying to do, is optimize all of those together rather than having, you know, this sensor with that measurement and this sensor. We're trying to incorporate those all into one system. And so how are we going to get that information off of that popsicle stick? And so that brings us to communication. So our communication is going to be either wired or wireless. And so we can kind of talk about the pros and cons of that all day long. There's a lot of people in each camp. But the big thing is if we went completely wireless and we wanted to transmit data from here to the other side of campus, we'd need a car battery, or we'd need a battery probably the size of this table, just to get that much power. Now, if we completely did it on the other end of the spectrum and we wired everything, 100% wired, and we had 200 sensors in here and we had to run those all the way back to the main campus, we'd have 200 wires going all the way back to the main campus, and you have all those wires that somebody had to sit there and splice. So there's a real big trade-off there with flexibility and power. And so the real thing that we come down to is it's really better to do a hybrid system. We've got a wired system and a wireless system. And so for any long distance that we need to do, we can go with the wired system. And for anything that needs to be really mobile, I need to be able to move this plant from this side of the greenhouse to that side of the greenhouse, we're going to go with the wireless system. And that really gives us the best of both protocols. So here's an image of a graphic representation of what it would look like inside of a greenhouse. And we're just going to assume that this is on a conveyor belt at this particular time. And so we've got these plants here. And you can see here's a potted plant, or a pot that's got soil in it and our sensor. And so that sensor right there obviously has no wires to it. It's got a small battery. It's standalone. There's nothing else that it needs. It's self-contained. And so the environmental conditions that that particular pot sees is going to be indicative of the ones that are around it. Okay, so you're going to say if it gets this much water in this pot, that we're going to say that it gets a similar amount in that. If the temperature in that microclimatic region is this, we're going to say that those plants around it are going to be very similar. And then we have this one over here, and we say, okay, different parts of the greenhouse are going to have different temperatures, different humidities, different soil moistures. And so we'll be able to go back and say, okay, this part of the greenhouse, it's had this much heat and this much temperature, or this much, or it was this hot for this long. And we can say it's got this much moisture in the soil and say, okay, well, we're kind of worried about the fact that it's got too much water in the air, so it might be prone to having a fungus grow in there. So we can just go ahead and treat that one side of the greenhouse rather than the entire greenhouse as kind of an early warning stage or an early prevention type scenario. So if we step back from that and say this is the entire greenhouse, each one of these blue wireless signals here would be one of those sensors. These gray dots here, or the gray circles, would be what we're going to use as repeaters. And again, that's that connection between the wireless and the wired. So this cluster of sensors is too far away from the main base station to wirelessly transmit back. So we don't have enough power to do that. Again, so we're going to have that wired system that goes back, and that allows us to reach further than we can do with our wireless and manage the size of that battery. So that would be the inside of a single greenhouse. Now, if we zoom out a little bit further, it becomes even more evident why the wireless-wired combination is great. Inside of our greenhouse, we're going to have all that wireless capability. We're going to be able to move plants around. If you put them on a conveyor belt, that's fine. If you need to rearrange your experiments, that's great. You can figure out where those sensors are in relation using the wired sensor or the wired repeaters. They can triangulate those sensors. But if you've got multiple greenhouses, obviously it's not feasible to transmit that data back to the main collection point. So that's where that wireless or the wired backbone comes in really handy and allows us to cut down on the size and cost of that battery. So what is going to be in that wireless sensor? That little red sensor that we were talking about that goes into the pot. Well, here's a block diagram of that. These are all the different sensors that are in that in the microcontroller. And when you first look at it, if you're not an electronics person, even though it's a generalized idea, it's still kind of overwhelming. So let's kind of break it down and erase all this and start with the building blocks of it. So the main thing that we've got here is the microcontroller. That can be equated to your brain. Basically it says, okay, I've got all these sensors, but this is what I do with that information. It is really the locomotion behind the whole project. And so then we have our temperature humidity, relative humidity sensor. This one's really important because if you stress a plant at too high of a temperature for too long, or you've got too much moisture, you're inviting pathogens in. And so that's really a big problem for a lot of our growers and greenhouses. So that is one of the most important sensors we have. Next is actually a capacitive leaf wetness sensor and a capacitive soil moisture sensors. One of the things that we're actually really excited about, I've come up with a thin film capacitive geometry for a soil sensor and a leaf wetness sensor that's going to be something that's a little different than whatever else, or the watermark soil sensors that people are using now. This is really to get it down to the form factor that we can use it like a popsicle stick and stick it into the plant and be able to get, or into the pot and be able to get this information. We're kind of excited about that, and so we can talk about that later. So the real-time clock here is allows us to add a time factor to all of these. Your temperature, your soil moisture, your leaf wetness. Those sensors there, all they say is it hot? Is it cold? Is there water on the leaf? Is there water in the soil? At that particular time that you ask it. Once we add a real-time clock to it, you can say, okay, on Tuesday at 2 o'clock in the afternoon, it was 78 degrees. There was no water on the plant. There was no moisture. That plant's stressed. And so by being able to do that, we can see what the trends are and what potentially would stress the plant. Finally, the last thing that we're going to add is going to be our wireless transceiver. And so we've also added a battery here because of the fact that that's really what makes it flexible. Okay, that allows us to move it around the greenhouse. And so the wireless does two things. First, it allows us to transmit data out of this particular environment, out of the microcontroller. It says, okay, I've got all this information on this particular location in the greenhouse. I can transmit that out. The second thing that it allows us to do is it allows us to triangulate where that particular sensor is. So as long as it's within 2 of the repeaters, we can triangulate where that's at in the greenhouse in respect to those 2 sensors and say, okay, this group of plants was the one that was having this type of problem, this type of stress. So this right here was the first prototype that I built, and obviously you can see that it is very complex with all the wires, and it's on a breadboard. But if you think back to the building blocks of it, you can see it. Right here is the microcontroller, and that like I said, that right there is going to be all of the brains of our particular operation. And then you can see here what we have is the temperature and relative humidity sensor. And then we have our real-time clock here, and then our wireless transceiver here, and then our soil moisture with the soil moisture probe in the back in the soil. And again, all that's doing is saying, is there water in the soil? It's not saying how much water. The soil moisture sensor and the leaf wetness sensor, those 2 are relative sensors. You're saying, okay, yes, there is soil or water in the soil, or yes, there's a lot of water in the soil. You're not saying there's this much or that much. And with the leaf wetness sensor, you're saying, okay, there's some water on the leaf or there's not water. After that particular prototype, we actually moved on to a copper-clad board. And this here is that soil moisture sensor that we were talking about the capacitive soil moisture. You can kind of see a little bit better there. And the way that works is it says, okay, you've got this much soil and water between those two pads, and as you take water out, the capacitance goes down. So that right there is the geometry of that. We're kind of excited, like I said, about that. And as you can see, there's still a lot of room that we can go for miniaturization and optimization on this. There's a lot of empty space on that board. And then we've also still have the battery off board. So with all of that, what is the expected outcome of this particular project? The final product of this is what we're wanting to have is an automated plant monitoring system. And so we want to be able to have a near real-time monitoring system that both gives us a temporal element as well as a spatial element. We want to say, okay, if the temperature is 78 degrees and we haven't seen water in 2 days, we want to turn on a sprinkler. We want to make it less conducive to the plant to have that pathogen invade. We want to be able to make decisions based on what those environmental conditions are, and we want to be able to do it in specific points in the greenhouse. And we want to make this low cost. We're talking about tens of dollars, not hundreds of dollars. That way you can put 40 or 50 of these in your greenhouse and get a better idea of it generally all around. And so how are we going to evaluate this product? How are we going to say we were successful? And so the three things that we're going to worry about is accuracy. Are you able to say it's wet in the soil, it's dry in the soil, it's saturated in the soil, it's hot, it's cold? Are you going to be able to follow the dynamic response? The repeatability is a big one. And so our particular lab, we have an environmental control chamber that we can actually validate this with and say, okay, this is what the ramp was and this is what we worked with. And we were able to record this data, and it was the same when we did it again. So with all of that said, are there any questions?
16 minutes, 49 seconds. Questions for Steve?
Yes, sir.
Yeah, so a lot of this instrumentation and obviously technological development to improve your product, it would sound like it is a big capital investment. And so is there a certain crop market that you're trying to gear towards? Because if you're managing a smaller crop, that's something more expensive, that makes sense. So I don't know if you
well,
sort of have an idea on that.
the point of this particular project is really to go for high value things that we grow in a greenhouse. It's obviously there's a lot of capital that goes into growing any plants in a greenhouse because there's just more that goes into it. You have to have more control over it and everything. And so plants such as chrysanthemums, African violets, poinsettias, things that you would grow in there that need to be timed to a specific thing. And so you have the potential in there to breed a large environment for pathogens. So the loss of the entire greenhouse product is going to outweigh the cost of these sensors by magnitudes. Yes?
Yeah, well, I mean, there's been equipment for greenhouses for decades. Are you going to compare yours with standard equipment that greenhouses are using?
Absolutely, absolutely. We'll be looking at a lot of the different sensors that are currently on the market. As far as a lot of the stuff that we've done research on is mostly, instead of being a localized climate around specific areas of the greenhouse, they've been more of a generalized, okay, the temperature in the greenhouse is this. And it's more of a rough estimate of parts of the greenhouse rather than the microclimatic regions that we're looking at. We're looking for, I guess, a more accurate representation of what they are. But those are all sensors that are more one measurement systems. Okay, so we've got this one over here measures temperature, and so it controls our fans, and this one over here measures whatever we need to measure to get our irrigation. And so yes, we will actually compare those as well. Yes.
How do you calibrate these sensors? How do you know the sensors are telling you the truth?
So that's what I was talking about, the environmental chamber. We can run that through our temperature ramp and a humidity ramp, and we can get those calibrated as well. And then we can also measure soil moisture for by volume, and we can get a rough estimate on that. Now again, the soil moisture sensor and the leaf wetness sensors, those are both relative. They're not meant to say, okay, you've got 33% moisture by weight or by volume. They're just saying, okay, it's dry. We haven't been watered in 3 days versus, a specific amount. Yes?
You have not mentioned anything about the spatial distribution of temperature inside the greenhouse. We're doing such kind of thing in a high tunnel, maybe it's different then. But when I look at the temperature sensors, which we had like 20 or 30 of them distributed in the greenhouse, there was no such kind of big difference. So my question is there any evidence in the literature that is showing that, okay, if we have a temperature sensor very close to the crop, it could show us a different temperature rather than hanging a couple of temperature sensors inside the house?
What we're aiming at trying to do is really try to figure out why a particular disease happens in a greenhouse. That is the step beyond what the sensor is actually designed for. And so the idea is we're trying to capture as many variables as we can. So temperature happens to be one of the ones that they're most concerned about, that relative humidity. So we've included that one, not so much to say, okay, it's different here and here, but if it were different, and if there were a disease, could you say, without a doubt, with your 20 or 30 sensors versus 200 or 300 of these in a 2 or 3 acre or whatever, could you without a doubt say the temperature was not? And so that is included on here, and if they find out that potentially it's not a relevant variable, then in phase 2 it will be taken out. That way we can.
So do you have any plan to like do a case study thing to prove that, okay, in this case, if we have these like sensors scattered, it's better we could
Once the analytical tool is made, I mean, at that point you can start doing case studies on those things, but that would be beyond the development of the tool itself. Yeah.
Last question.
Oh,